Astronomers have found a mysterious dark galaxy that doesn't produce any light that can be seen. More than 90% of it is made up of dark matter, with the exception of a very small number of stars. The scientists initially believed it to be a typical dwarf galaxy with few stars. However, a thorough examination of the galaxy revealed that it is an anomaly that defies all predictions. Its characteristics put our knowledge of extragalactic astronomy to the test. The missing satellite conundrum, one of the largest astronomical puzzles, might also be resolved by this dark galaxy. But how did astronomers discover it in the first place if it doesn't emit any visible light is an intriguing puzzle. How exactly did they come to the conclusion that it was a galaxy millions of light years away? Finally, and most importantly, what's the missing satellite problem that has puzzled astronomers for decades? You will get to know this and many more as we dive into details. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. Galaxies vary in a wide range of sizes and shapes, but the fundamental components seem to be pretty constant. There's typically a large black hole at the center, along with a number of stars and gas, and a sizable amount of dark matter that holds everything together. The stars, gas, and swirling core of hot material stand out with the bright brilliance of a city that night. In contrast to the, dark matter, researchers have found a weird galaxy that doesn't produce any visible light. The first dark galaxy in nature has been discovered 94 million light-years away is a lonesome object. More than 90% of it is made up of dark matter, with the exception of a very small number of stars. The scientists initially believed it to be a typical dwarf galaxy with few stars, but a careful examination of the galaxy revealed that it is an anomaly that defies all predictions. Its characteristics put our knowledge of extragalactic astronomy to the test. The missing satellite conundrum, one of the largest astronomical puzzles, might also be resolved by this dark galaxy. One of the most significant open questions in current physics concerns the precise makeup of dark matter and dark energy, which together are thought to make up of 96% of the observable universe. Dark matter does not absorb, emit, or reflect any electromagnetic radiation, making it invisible to the naked eye. Therefore, despite intensive efforts, astronomers have not been able to directly study it. The fast J0139 plus 4328 dwarf galaxy, which is 94 million light-years from Earth and was previously unknown, has recently been found by astronomers. This galaxy is particularly interesting because it appears to be composed almost completely of dark matter and does not appear to be emitting any visible light at all. Unsurprisingly, this kind of galaxy is referred to as a dark galaxy. These discoveries offer observational proof that fast J0139 plus 4328 is a solitary dark dwarf galaxy, according to a recent publication by researchers at the Chinese Academy of Sciences in Beijing. An isolated dark galaxy has never been found in the neighboring universe. It is also challenging to grasp precisely how a galaxy like this forms and what function dark matter plays in the formation of galaxies like our own, because we still don't fully comprehend the nature of dark matter. Some researchers even wonder whether dark matter actually exists and whether another phenomenon might be able to account for the puzzles that dark matter is supposed to answer. Perhaps the recently discovered dark galaxy will offer hints that one day will help to finally solve the mystery. One of the most significant mysteries in extragalactic astronomy is the missing satellite problem, commonly referred to as the dwarf galaxy problem. There's a disparity between the number of dwarf galaxies that have been discovered and the number that the LCDM model and cosmological simulations anticipate. Small galaxies known as dwarf galaxies can have up to 1 billion stars. They move in a similar fashion to natural satellites around larger galaxies like the Milky Way. The Milky Way satellites include objects like the Large and Small Magellanic Clouds, the host galaxy's gravitational potential affects the dwarf galaxies, but they are stable astronomical objects in and of themselves. Over time, numerous dwarf galaxies have been found, bridging the discrepancy between the observed and predicted numbers. Even a 2018 publication asserted to have found the solution to the missing satellite issue. However, there's still another issue, so this is only a partial fix. It has to do with the finding a peculiar class of dwarf galaxies known as UFDs, or ultra-faint dwarf galaxies. They are among the faintest galaxies known in the universe because they only have a few hundred to a few thousand stars. Dark matter predominates in their structures to a large extent. They hold important information about the origin of the universe, which is why astronomers are interested in them. The oldest galaxies have been found so far are all UFDs, having formed only a few 100 million years after the Big Bang. The most exciting phase is about to start. The principal subject of this study, dark galaxies, may be the cause of the ongoing missile satellite issue. A typical galaxy has a supermassive black hole at its center, along with gas, dust, star clusters, and a halo of dark matter. Dark galaxies, on the other hand, are objects that are dominated by dark matter alone and have almost no visible stars in them. They are dark matter halos, which up until this point have been unable to spark star formation. Their discovery might provide a comprehensive solution to the issue of the missing satellite by illuminating why ultra-faint galaxies are so rare. They were only hypothetical up until now, but now scientists have discovered the first dark gray galaxy in the natural world, which only need to respond to two questions in order to comprehend this revelation. The first is, how did astronomers discover black galaxies if they don't emit visible light? The 21-centimeter line in particular is projected to be emitted by dark galaxies, which is predicted to have measurable levels of neutral hydrogen gas. This spectral line is created when the spin of an electron in a hydrogen atom flips to become anti-parallel to the spin of the proton. In the radio portion of the electromagnetic spectrum, this spin flip results in a spectral line with a wavelength of 21 centimeters. However, not all HI or hydrogen clouds are dark galaxies. They might be clusters created by tidal forces, tidal debris, or materials taken from some galaxies. Therefore, dark galaxy candidates should be remote and unrelated to other galaxies. Blind HI clouds are solitary, neutral hydrogen clouds like this. They aren't connected to anything astronomical. These clouds are found through HI surveys, and this study team used one of them. FAST, or the 500-meter aperture spherical radio telescope, was used to make the finding. They discovered a potential candidate and gave it a name based on its celestial coordinates. 28 megaparsecs, or 94 million light-years, separate us from this HI cloud, which equals a redshift of 0.0083. Now that we have used radio waves to identify a probable candidate, we must respond to the second query. What led astronomers to the conclusion that it was a galaxy? The answer is morphology, which is the study of HI clouds' form and organization. 3 significant cues discovered by astronomers proved that it is, in fact, a galaxy. The analysis of column density maps reveals the first, which is the distribution of neutral hydrogen gas within and around the cloud. The cloud structure appeared to be highly compact according to this indication. The second hint came in the form of a double peak in the global HI or atomic hydrogen profile. This chart shows the flux of neutral hydrogen as a function of the gas's movements velocities along the line of sight, as well as the intensity of the emission line's 21-centimeter length. It indicates the disk-like structure of this graph has 2 peaks. Why? It shows that the gas clouds are revolving around the galactic nucleus. The disk's approaching and retreating sides are represented by the 2 peaks. The position velocity diagram of the HI cloud provided the last piece of information. An S structure was visible. Each position is tracked according to its velocity on the position velocity diagram. The spiral arms of a disked galaxy's 2 ends are represented by the 2 ends of the S shape. Additionally, the double peaks in the global H1 profile or the disk's regions are represented by the central dark regions. The astronomers were therefore able to determine that it is a disk galaxy and not merely an HI cloud thanks to these 3 criteria. However, being isolated is a requirement for an ideal dark galaxy. That is, the lone galaxy was the last astronomers needed to confirm. They investigated photos taken in various wavelength bands of the galaxy and its surrounds for that purpose. The electromagnetic spectrum's optical near-infrared, near-ultraviolet, and mid-infrared ranges were among them. Take a look at the researchers' paper's graph. The anticipated maximum diameter of the black galaxy is depicted by the inner red circle. The dashed circle has a diameter that is 3 times that. However, since it can only be detected in radio wavelengths, the galaxy cannot be seen from here. The optical stars in the yellow and black disks were found by the Gaia expedition. It is obvious that the stars in the image are within our galaxy and in our line of sight because Gaia only examines the stars and other objects in the Milky Way. They're not a part of the dark galaxy as a result. Additionally, parallax was used to determine that the distance to the farthest star was approximately 13 kiloparsecs, which is well within the range of our galaxy. The illustration unequivocally demonstrates that the black galaxy has no visual counterpart. Then, neither the near-infrared nor the near-ultraviolet images revealed any evidence of star formation or galactic neighbors that might have been visible in these 2 bands. Last but not least, the radio emissions from this galaxy are limited to the neutral hydrogen line at 21 centimeters. This proved that it was the first ever discovered isolated dark galaxy. The astronomers compared it to galaxies that are similar to it in many ways. The baryonic Tully-Fisher relation, or BTF relation, was used first. This shows a graph between the galaxy's rotational speed and its baryonic SS. The resulting graph demonstrated that the recently found galaxy is an ordinary disk galaxy, but another graph revealed that it is an anomaly. They discovered that the HI mass-to-light ratio stands out in comparison to low surface brightness galaxies in black and practically dark galaxies in green when they examined the relationship between the two. They came to the conclusion that this is one of the darkest gas-rich galaxies ever found. The baryonic mass of the dark galaxy found by FAST is 100 million solar masses, and its dynamic mass is 5.1 billion solar masses. Within the galaxy, stars and gas make up the baryonic mass. These two numbers ratios suggest that this galaxy contains a significant amount of dark matter. Furthermore, given that it has no stars, its characteristics imply that it might be in the early stages of galaxy formation. Thus, it's possible that we discovered a newborn galaxy that is still in its cradle. By finding these obscure galaxies, we can better comprehend galaxy evolution. Finally, it might provide an explanation for why ultra-faint dwarf galaxies are so uncommon. Recently, using backyard telescopes, amateur astronomers found a fascinating structure near Andromeda Galaxy. Astronomers have been baffled by this enormous structure as they try to understand its genesis. Do let us know your opinions in the comment section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos. Thanks for watching, and we hope to see you with the next one.